Okay, intro to logarithms. The word log is short for logarithm and represents the exponent or the power to which a fixed number called the base must be raised to produce a desired number. An expression in logarithmic form such as log base 2 of 32 is read log base 2 of 32. To evaluate, what you think to yourself is, what exponent is needed for the base of 2 to become 32? And the answer is 5. So log base 32 is equal to 5. An equation in logarithmic form is equivalent to another equation in exponential form shown below. This conversion is why y equals log base b of x and y equals b to the x are inverse functions for b greater or equal to 0. So this right here, or I'm going to end up writing it a lot later, and I'll write it as I'm actually going to write it as b to the a equals c. That's the same thing as log base b of c equals a. You can switch the variables around, but here's what you need to notice. B is the base of that exponent. B is the base of your logarithm. Then also notice in my first equation, the b and the a are together on the same side of the equation. But in my second one, they are no longer together. So that could help you put them in the right spots. Before we get started on logarithms, we need to know all of the exponents listed below. So, no calculators. You need to have memorized 2 to the power of 2 all the way to 6, 3 squared, 3 cubed, 3 to the 4th, and then 4 through 10 squared and 4 through 10 cubed. So pause the video and see how many of those you can fill out on your own. 2 squared is 4, times 2 again is 8, times 2 again is 16, times 2 again is 32, times 2 again is 64. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. Keep going. See how many you can fill out. Okay, check yours with mine. So all these numbers, I wrote mine in purple. You need to be able to recognize them as being something to a power. So when I see 343, I need to think, oh, that's 7 cubed, because that's going to be so important. So work on memorizing this little box here and these purple numbers. On the left side, there are some special properties of logarithms. Doesn't matter what the base is. If you're taking the log of 1, it will always equal 0. If your base of your logarithm matches the base of an exponent and you're taking the log of it, the answer is literally just the exponent. And then kind of the same idea in reverse. If you have a base raised to the log of the same base, the answer is just whatever you're taking the log of right there. And then if there is no base written, if it just says log of x, there is a little imaginary 10 to be assumed written there. So if it's just log, it's base 10. Okay, so here we go. How do we use this? So question 1, we are asked to do log base 3 of 9. First of all, there's no calculators and a calculator is not helpful for this. We want to use our rewriting feature. So let's write it at the top here. I had told you b to the a equals c. That can be rewritten as log base b of c equals a. You can go in either direction. Sometimes it's helpful to go from exponents to logs. Sometimes it's helpful to go from logs to exponents. So at first, we will write it down. So number 1 says log base 3 of 9. So it's written in this form. I want you to rewrite it in this form. So the base is the tiny, tiny number. Start with the base, 3. Sometimes we draw this little arrow thing to help us out. 3 to what power equals, and the only thing left is 9. When you see log base 3 of 9, you think to yourself, 3 to what power makes 9? Well, a power of 2. That's why you need to memorize those powers from that other table, right? That's the answer. Logarithm problems are so easy once you get the hang of it. You're often going to be quizzed by me in class. hey, what's log base 2 of 8? And you're just going to be able to give me the answer off the top of your head. One of the nice things is the numbers can't be that big, right? I showed you, let me go back. I showed you all these exponents we need to memorize. Well, the answer to a logarithm is an exponent. So the only exponents you could possibly give me so far are between like 2 and 6. We might throw some negatives in there in the future and some fractions in the future, but you're not going to have answers bigger than 6. So see if you can rewrite number 2 as an exponent problem. If you don't know what to do in log form, change it to exponent form. Circle the base, raise to that number. 2 to the 8th equals x. Look, we got x by itself. Did I tell you to memorize 2 to the 8th? I did not, so it's perfectly fine to leave it as 2 to the 8th as your answer. However, if you happen to know or you want to do the multiplication, that is 256. So either way, if the answer was 2 cubed, you would not be allowed to just leave it. 2 cubed is 8. But if it's something outside the range of the chart we asked you to memorize, you can just leave it as 2 to the 8th. Rewrite number, these numbers are all mixed up. I'm going to keep going sideways. So rewrite number 11 for me. Five to the x equals 125. So for today, you might have to go back and look, but by test day, you need to have it memorized. 5 times itself, how many times, right? An exponent. 5 times itself 3 times equals 125. Okay, let's follow the way the numbers are written now. So number 3, rewrite it. 5 to what power equals 125? 1 over 25. Okay, here's the thing that you need to remember from reviewing exponents with us. If you have 1 over b to the nth power, that's the same thing as b to the negative nth power. So negative exponents, put it on the bottom of a fraction. So 5 to what power is going to make 1 over 25? Well, 5 squared makes 25, but if I want it to be 1 over 25, I need a negative. Negative 2 is the answer. Keep going in order. So number 4, rewrite it. You should be getting good at rewriting these now. 7 to the 0 equals x. Anything raised to the 0 power is 1, so the answer is 1. That was also one of those special properties if you happen to memorize it, but changing it to an exponent should help you also. Number 5 starts with a 9. 9 to the 1/2 equals x. 1/2 powers, again, remembering your exponents review. If you have I'm going to use a root of x to the b, that's the same thing as x to the b over a. So a root goes on the bottom of a fraction. So if I just rewrote that as 9 to the 1/2, that's the square root of 9 to the 1, right? Square roots have an imaginary 2 that we don't usually write. And the square root of 9 is just 3. Fractional exponents are roots. Okay, number 6. Do you remember the special property? If you don't, I'll rewrite it. 9 to the x equals 9 to the 5th. Well, these match, so the exponents must match. X equals 5. But if you remembered the property, it's kind of like the log base 9 of 9 crosses out, and the answer is just 5. See if you can do 7 and 8. Pause the video, see if you can do problem 7 and problem 8. Okay, number 8 was another one of those special properties. Log base 8 of 8 goes away, and the answer is just the exponent. Number 8, did I say 8 earlier? Sorry. Number 8, rewrite it as an exponent. Now I'm trying to figure out what times itself 4 times makes 81. Over here, 3 to the 4th makes 81, so my answer was 3. 9 is another one of those special properties. 3 to the log base 3. The answer is just the exponent, 7. The value, sorry. Log base 10, well, I gave it away. There is no base, but there is an imaginary 10 there if there's no base written. And then of 10 to the 7th crosses out, and the answer is just 7. We already did 11, number 12. These don't look too bad. See how many of the last ones you can finish solving. Pause your video. Okay, maybe you got stuck on number 12. Rewrite it and you get 49 to the x equals 7. This seems weird, right? Because the exponent is on the bigger number. So I don't want to multiply 49 times itself more times. I want to take the square root, right? The square root of 49 makes 7. Remember how to get a square root? You're taking the second root of something. So it's 1/2 power. 2 to the negative 3 equals x. Negative exponents make it 1 over, and 2 times 2 times 2 is 8. 4 to the x. How about x to the 4th equals 16? What times itself 4 times makes 16? 2. 2 times 2 times 2 times 2 would give me 16. See if you can do the last one. So again, it's kind of weird because the exponent is on the bigger number. I don't want to multiply 81. I want to take a root of it. The 4th root, so 1 over 4, because 3 times 3, etc., 3 to the 4th is 81. So I need to take the 4th root of 81 to get 4.